Hello, my name's Corrine and I'm a dance artist here at The Place in central London.
Hi, my name's Michael and I'm a musician here at The Place.
The Place is a powerhouse for dance and is home to London Contemporary Dance School, a 280-seat theatre, a professional development programme for artists, and an extensive range of classes, courses and participatory opportunities for adults and young people. The creative learning team at The Place is dedicated to bringing more dance to more people. Through our Partner Schools programme, we engage with over 700 children in Camden each year with an aim to inspire creative dance activity. We want to give children the chance to experience dance in their lives and provide teachers with the confidence to embed it in their school's curriculum permanently. The Place is also an Artsmark partner and supports schools throughout their Artsmark journey. We offer CPD for teachers, deliver cross-curricular projects in schools, and provide opportunities for pupils to see professional shows. One area of the framework we wanted to briefly highlight in this video is curriculum design. The curriculum design criteria explores how a broad arts and cultural curriculum is embedded throughout the school and how this can increase children and young people's knowledge, skills, and understanding of the arts. Using the expertise of arts organisations such as The Place to facilitate engaging ways to introduce and develop topics can help schools with this criteria. For example, in this video, we're going to explore how dance could be used within the science curriculum. Techniques you learn here could then be applied to other topics and subjects throughout your school. Today, we're going to use dance to explore the topic of electricity. Have you ever thought about what the entire visible world, you, me, and everything around us is made of? Have a think for a moment. Maybe you thought of particles or atoms, and that's right. We know that the entire world is made up of tiny particles called atoms. And each atom is made of even tinier particles, positive and negative charges. And they are so tiny that there are more charges in the tip of your finger than stars in the visible universe. Have you ever felt a small electric shock when you take a jumper off or touch someone or something like a shopping trolley? If the answer is yes, then you have felt charges. When charges flow like this, we call them electricity. And although charges are tiny, they can be very strong and powerful, as we're going to see in this experiment. When two different materials are rubbed together, the negatively charged particles known as electrons can be transferred from one object to the other. So, as I rub the balloon against my jumper, the negative charges are being brushed off the jumper and onto the balloon. And the balloon is now gaining an excess of electrons and becoming negatively charged. Now, let's see what happens when I hold the balloon over these tiny pieces of paper. Hey! Ah. Did you see that? The excess of negative charges on the balloon attracted the positive charges in the pieces of paper, and opposite charges love to be together. Think about the immense power of these tiny charges for a moment. The paper is being pulled downwards by the gravity of the entire Earth, and a few tiny charges are lifting the paper up. They are very strong indeed. Great, so now let's have a go at this idea with our bodies. If you need to, you can pause the video so you can clear the space so you've got plenty of room to move. So, we're going to imagine that our bodies are a piece of paper. So you're going to have a go at folding and unfolding your body. See how you can use your body in different ways to fold in and unfold. And maybe you use your elbow or your wrist or your knee. Any part of your body you might fold forwards or sideways or backwards, and have a little play. Fabulous. Now you're going to keep folding, and you're going to think about folding all the way down to the earth. How can you fold and unfold your body to the ground? Are you there? Fabulous. Right, now we're going to imagine that there is a giant negatively charged balloon above us. And so when we're on the floor, our paper is going to be drawn up to the balloon. So thinking about how the paper is attracted up, up, up towards the negative charges in the balloon. Lovely, keep folding and up all the way till you're up. And then we're going to relax. Fabulous, let's go again. So up. Keep reaching up, lovely, and relax. Fabulous, we're gonna go once more. One more time. We're gonna think about being lots of little pieces of paper this time. So really think about all the movement that we saw in the experiment. The paper dancing up, being attracted up to the balloon. And relax. Very nice. Wow. Those tiny electrical charges are so strong, they lifted you away from the earth. So you could try and explore this in many ways. You might imagine that there's a giant balloon and it could be your teacher and they could be at one side of the space. And you might see what happens to the paper children as they're drawn across the space to the balloon. And the balloon can move around and then see what happens. You could also try with a pair. Michael, would you like to come and join me? And you might imagine that one of your hands is positively charged and one of your hands is negatively charged. And you're going to draw and attract that person's hand and body across, around the space. You might travel in different directions, up and down. You might take them on a journey across the space. Thank you very much. You could also try on your own, and you might imagine one part of your body is positively charged, one's negatively charged, and how they might attract and move like that. So have a go. If you want to pause the video now, you can do. Now, the most spectacular example of charges flowing to make electricity is lightning. As a giant thundercloud forms, lots of small ice crystals move around inside the cloud. As they bump into each other and collide, some negative charges get knocked off, just like the negative charges getting knocked off the jumper and onto the balloon. The negatively charged ice crystals sink to the bottom of the cloud, and the positively charged ice crystals gather at the top. And we've seen that positive and negative charges love to be together, and lightning occurs when the attraction between the positive and the negative charges is so strong that they push through the air towards each other and spark, either within the cloud or down to our more positively charged earth. Lightning is just like the spark you sometimes feel from your clothes or when you touch something like a shopping trolley, but on a much bigger scale. Great. Let's have a go at a thunderstorm dance. So to begin with, you're going to start imagining that you are a cloud. Soft, light, full of air, and floating up in the sky. Fab. And gradually, some ice crystals are going to start forming in your cloud. And they're going to become more frequent, and they're going to start knocking and bumping into each other, colliding. And as they're colliding, they're going to start knocking the negative particles down, and they're going to sink to the bottom of the cloud. And the positive ice crystals are going to start gathering at the top of the cloud. And they're going to want to be together so much that they're going to shoot through the air, and they're going to create lightning. Now, let's have another go at some lightning. So, can you find another lightning shape? Here we go, and lightning. Great. Let's have another go at our thunderstorm dance. Are you ready? We're going to start with our cloud. our ice crystals are going to start to form. And they're going to get more frequent and they're going to start bumping into each other. And they're going to get more lively and bump even more, collide, and they're going to start knocking charges off each other, and our negative charges are going to gather down at the bottom of our cloud and our positive charges at the top. And they're going to want to get together so much that they're going to make some lightning. And some lightning. And some lightning. Brilliant, well done. So you could have a lot of fun with this in a group as well. You could arrange your class into 2 groups, positively and negatively charged ice crystals, but have them spread out and all mixed up to begin with. As everyone does their colliding ice crystal dance, the positively charged group can travel through the space and gather on one side, while the negatively charged group travel through the space and find each other on the other side. See how you can find a way to show the lightning strike as a charge of electricity flowing between the 2 groups. Okay, so let's just have a reminder of the key learning points we looked at today. For more detail and other ideas for exploring this topic through dance, please refer to the handout notes linked in the video description. Thank you so much for watching, and we hope that this video will give you some ideas of how you can enhance subject learning in creative ways. Working with organisations like The Place can support you to embed their area of expertise into your school. If you would like to find out more about how we can support your Artsmark journey, please get in touch.